Okay, in this video, I want to talk to you about the man named Pythagorean that came up with the Pythagorean theorem that deals with right triangles, where he stated if you have two of the measurements and you follow his formula, a squared plus b squared equals c squared, you could know the third measurement. Even if you have these two, you could figure out this one. And even if you have these two, you could figure out the missing side. I wrote them all there because I want to make it easy for you to understand what I'm trying to explain to you. And in this situation, I'm going to make it a little darker for you. Now this only works with right triangles. This is notated by that little square in the corner there. And that notates that it is a right triangle, which means that angle has 90 degrees. It's a 90-degree angle. Okay? The 5 is on the hypotenuse. That's the hypotenuse's length. And the hypotenuse is the diagonal right here. These are called legs, and that is called the hypotenuse. The hypotenuse is always across from the right angle. Okay? If I were to do this math on paper, I would say, well, first I would use the formula a squared plus b squared equals c squared. And so I would say, I would name this A, this B, and the hypotenuse is always C, okay? The hypotenuse is always C. So I say 4 squared plus 3 squared equals, in this case, it's going to equal 5 squared, okay? So I'm getting 16 plus 9 equals 25, and that's true. But if I only wanted to know what the length of 5 was, if I hadn't shown you ahead of time, I would have to take the square root of 25 to come up with the answer 5. What is the square root of 5? Which means what number do I multiply by itself to give me 25? And I could have gotten the length for C. But what I want to show you that's kind of nifty is you can do this in the calculator, okay? And you can do it in one nice, well, it's a few steps, but all of it can go in the calculator at the same time. So you're going to press your second key and you're going to press the x squared key. First, you're going to turn it on. Then you're going to make sure it's clear. Then you're going to press the second key and then the x squared key. Okay? In this situation, we knew it was 4 squared plus 3 squared. Let's say we didn't know what the other side was. If we press enter right now, it's going to tell us. And it gave us the number 5, okay? But if we had, and that was the hypotenuse, the diagonal piece. But let's suppose we had the number 5, then it has to be a subtraction problem. And we would say second x squared, and we would say 5 squared, and we have to take away this time, and we could say 4 squared. And we should end up with that other side, and it should be 3. Let's see if it does it for us. It does. Now this time we're going to try and act as if we had the C again, which was the 5 squared. But this time we have to take away, and we're going to take away, did I get that right? This time we're going to, oh, we can't stay up high. We got to get out from under there. I'm glad to make a little mistake so you can know what not to do. We got to get out. We can't stay up when we squared it. We can't stay up high. We got to get down. So we push that arrow to get down, and we say minus. And in this situation, it's 3 squared. And if all goes well, we end up with the 4. See? So when we have A and B, it has to be an addition problem. But if we happen to have C, it has to be a subtraction problem. You can say 5 squared minus 4 squared. And when we hit the enter sign, we'll end up with the 3. Or we could say 5 squared minus 3 squared. And when we hit the enter sign, we're going to end up with the 4. So if we have the legs, it's always an addition problem, like what we did here. But if we have the hypotenuse, which is always going to be the C, it's going to be a subtraction problem. And if you need me to help you make a little more sense of that, think about something like this. 3 plus 4 equals 7. and 4 plus 3 equals 7. But if we had the 7 to begin with and we needed to find one of the others, it would have to be a subtraction problem. We had the 3. If we took it from the 7, we'd know the missing number was 4. Or if we had the 7 and the 4, it'd have to be a subtraction problem to find the 3. Okay, I hope that's helpful to you. Thanks. Have a good day.